Now, hello everyone. Now let's continue with other family of the organic compounds. So now we are going to be looking at ether. In the previous video, we've looked at alkane, alkyne. Now let's quickly take a look at ether and how to name some compounds that are ether. Very simple. Ether is otherwise known as alkoxy-alkane, which is ROR, more like alkyl separated by oxygen. So where is the alkane part? Where is the alkoxy part? The alkane part is the longest chain, while the other one is the shortest, the other part that is short. Now let's take a look at this compound that is having CH3, CH3O, CH2, CH2, CH3. You can see that the number of carbon here is 1, 2. The number of carbon here is 1, 2, 3. The one of 1, 2, 3 is the longest, meaning that this is our alkane. So this part is the alkane part. This is the alkane part. 1, 2, 3 is propane. Now, but this part 1, 2 is the smaller part. 2 is earth. But once you're able to identify the longest part, you take that part out. Then the shortest part will go along with this oxygen that is here. Can you see the oxygen? Meaning that this 1, 2 is going along with this. That's why if you say 1, 2 is earth. So from the word alkoxy, what are we going to call it like that? It is going to be sounding 1, 2 with the O. We are going to call it ethoxy. Can you see the ethoxy? Yes, ethoxy. Then 1, 2, 3 is going to be what? Propane. So the longest part is the alkane. Then the shortest part together with the O, the shortest one together with the O is going to be the what? 1, 2 ethoxy, the alkoxy, and that is very, very clear. So I think we can move to a compound that looks like this. Now, some of you might be scared of this compound. If you know how to deal with a line formula, this should not be a problem. We can rewrite this structure if you believe with me. Let's take a look at how we can rewrite this. This part here is CH3. This here is CH2. That's it. Then here is C. Drag down here, having oxygen, then connected to another CH2, then connected to CH3, which is the last one here. Then this part is now connected to what? CH3. Now, if you take a look at this, the next question is, if I want to name this compound, this is the O that separates them. This O separates this one here, 1, 2, separates it from 1, 2, 3, 4. I think that is clear. So this oxygen here separated 1 to these 2 carbon from this 1, 2, 3, 4. So 1, 2, 3, 4 and 1, 2, which of them is the longest? We all know that the longest chain is going to be the alkane, while the shortest one will be the alkoxy, like I told you. So 1, 2, you should know that 1, 2 is the shortest together with the O, earth. This part will be ethoxy. This is the ethoxy. Now, but we now have 1, 2, 3, 4. Now, this is the longest chain. Now, you will notice that this our O of the O substituent that is here. Can you see this O? I mean, the whole of this that is here, which is an ethoxy. That's an ethoxy. That ethoxy is attached on the major parent here, the longest chain, which is 1, 2, 3, 4. Now, on what particular part is it attached on this carbon? So if I want to, I can give the whole of this guy a number, the smallest possible number. If I count like this, 1, 2, 3. The whole of this is in position number 3. If I count like this, 1, 2 is in position number 2. So 2 is the smallest, and 1, 2, 3, 4. That's butane because it's okay. I can say our ethoxy is in position number 2. That will make it 2. See, 1, 2, 2, 3, then 4. 2 ethoxy, 2 ethoxy, 2 ethoxy, then 1, 2, 3, 4 butane. 2 ethoxy butane. Very simple. Now I want somebody to draw this structure for me. Try to draw this structure yourself. This is a classwork for you. This is a classwork for you. See, if someone, why saying this name 2 ethoxy, mean that ethoxy is same thing as CH3, CH2 together with oxygen. ethoxy. Now say 2-ethoxybutane. I mean on a butane, the 2-ethoxy, I mean on a butane, ethoxy was attached to position number 2. That's why we call it 2-ethoxybutane. So if I write a butane which is CH2, CH3, CH2, CH2, CH3, which is that is a butane. They now said 2-ethoxy, 1, 2, position number 2. That's the meaning. And this one will not be there again. Then that's an ethoxy. Simple. So I want you to try this question that says structure of 1 bromo, 1 methoxyethane. In this case, we have ethane. Ethane is going to be CH3, CH2, abi ethane. Then methoxy is in position number 1. 1 methoxy. Can you see that? 1 methoxy, position number 1. I'm already answering the question for you. 1 methoxy means that if this is ethane, 1, 2, the guy is in position number 1. So connected to methoxy. So if this is methoxy, 1, 2, ethane. So 1 methoxy attached to 1, 2, position number 1. This is position number 1. This one is position number 2 of the alkane. So 1 bromo is also, so this is going to be the answer. CH3. Everybody should look up CH3. Then check, ensure you are checking it. CH3C. Say bromo is in position number 1 of the, because the main parent chain now is the alkane. So bromo, position number 1, abi. Then we have H here. Then it's now connected to what? It's connected to oxygen, connected to CH3. So it is so clear that the whole of our ethoxy is attached to this parent name, position number 1, position number 2. Bromo is also in position number 1. So I think that is clear. So you can try other questions. For example, if I give you something like this, I want you to try questions like this. I want you to try a question like this. I want you to try a question like this. Yeah. I want you to try this question yourself. Give me the name of this compound. Yeah, that is all about ether. Let's move to the next one. Now, today we are going to be looking at amine, which is different from amide. This is amine, not amide. Now, in our previous video, we look at ether, which is an alkoxy alkane. So ensure you check each of those videos so that you can know how to name all these. Now, for this first compound, this is amine. Amine has a functional group RNH2. This is an alkyl. So anytime you are naming this guy, you pay attention to the nitrogen we have here. Can you see this nitrogen? Now around this nitrogen we have some carbons here. Now you can see that this face is hydrogen, then this face is hydrogen. So in some cases we have carbon here, then we have carbon here, may have carbon here. So all you will go for is the longest side. You can see that this is 1, 2, 3. This is ending with HH, meaning that this side is the longest. So how do we name it? You pay attention to the first carbon that is attached to the nitrogen, which is also the longest part. So this face will be number 1, number 2, then this will be number 3. So meaning that our chloro, 1 chloro, 2 methyl, then count 1, 2, 3. 3 is prop. Prop will be propan, then the name ending is amine, propanamine or propanamine, anyhow you want to call it, or propanamine. Now that's that. So let's look at this one. I'm trying to write it back from the line formula. We can achieve this back in a line formula. This is same thing as CH3, then this space is CH2, this space is C connected to CH3, then H, that's this space, then this space is C, then our C is connected to H, then connected to N. It's connected to N, and our N is connected to something here, which is CH3. Then also, if you look at this part, also connected to CH3. Now, how do we name this guy? Now, firstly, we can say that we have carbon towards here, we have carbon towards here, we have carbon towards here. But which of them is the longest? This is giving 1, 2, 3, 4. This is just 1. This is just 1. Meaning this is the longest. So we are taking this to be the parent, which is the longest name. We are taking our root name here. So this is going to be 1, 2, 3, 4. 1, 2, 3, 4. Now, if you go this way, There are some guys we did not touch. Where are those guys? Can you see this guy? We did not touch this guy. We won't talk about this guy and this guy. So how do we deal with them? They become an alkyl group because they are not part of the longest chain. But now this CH3 is attached to nitrogen. This CH3 is attached to nitrogen. These two CH3 are not attached on this chain. You can see that the difference between this CH3 and this one is that this CH3 is attached to a carbon, these ones are attached to a nitrogen. So how do we go about them? How do we name them? In this case, we have 3-methyl. I mean, this is what 1, 2, 3. These are 3-methyl, but these ones are attached to nitrogen. These ones are attached to nitrogen, but this one is attached to a carbon. So how do we name this one? 1, 2. Our carbon is in. This is position number 1, this is position number 2, position number 3, position number 4. I told you, you start from the carbon that is connected to the nitrogen here. I think I said it then. So this is 1. Yes, this is 2. So that means 2-methyl. Methyl is in position number 2. But we have another methyl here. These are methyl. And these are another methyl. But the difference between these two methyl is that they are connected to the nitrogen. So the only way to sort out for these guys is to say N, N, they are methyl and methyl, dimethyl. Then you count the number of longest chain, 1, 2, 3, 4. 4 is going to be what? Butan. You know, I said propan, butan. Then the name amine, butanamine or butanamine. As simple as that. So if somebody give you this to name, immediately you look at butanamine, you know that the longest part there is 4 carbon that is connected to nitrogen. Then you saw NN dimethyl. It means there are 2 methyl that is on the nitrogen. Then you saw 2 methyl. 2 methyl means one of the methyl is on carbon 2 and the other 2 were on nitrogen. I think that is clear. If that is clear, I want you to try this question. So we are done with this one. We've looked at that. So I want you to try question number 3 yourself. Try question number 3 yourself and give me the answer. I've just given you the answer to question number. This is for number 2. So I need the answer for question number 3. Answer it yourself. Answer and put the answer in the comment section. Thank you so much. Now we are moving on to the next family of the organic compound, but in this case, we are going to be looking at alcohol. I want you to pay much attention here because this compound is more popular. You have to use this a lot in reactions, alcohol. So firstly, the functional group here is ROH, which is OH is our target. So when you see your OH is your functional group and it must be given priority anytime you are counting numbering. Now let's look at this compound. As simple as this compound is, students might make mistake with this compound. If I want to name this guy now, don't forget that the name ending of this guy, the name ending is OL. So if I want to name this guy now, I count 1, 2, 3, 4. Now I have this is my longest chain. After counting the longest chain, you can see that we do not have any uncounted carbon. So there's no need for alkyl group like methyl, ethyl, because this is all the longest chain. We do not have any uncounted carbons. Everything was counted. So what's then the next thing? The next thing is that how do I number it? Should I start from 1, 2, 3, 4? If I say 1, 2, it makes this bromine to be in position number 2, meaning that bromo will be favored. 1, 2, 3, but our OH will be in position number 3. You know, I told you that anytime you are numbering, we number in such a way that it is small. Because if I say 1, 2, this is 2, 2. Then this one will be 3. But if I say 1, 2, this one will be 2. Then this one will be what? 3, 3. So we might be thinking that 1, 2 will be better. But why are we going this way? Now, the reason why we will not go 1, 2, 3, 4, even though it will give us a smaller number, because this guy will be in position number 2. This will be 2 and 2. Then this one will be in position number 3. The reason why we are not going this way is as simple as OH functional group has more priority. It has more priority than the substituent. Is that okay? OH has more priority than double bond, triple bond, the halogen. So if I want to count, I have to count in such a way that it will make this guy to be smaller. 1, 2, 3. This guy is in position number 3. 1, 2, position number 2. So I have to go this way. So this is position number 1 for this guy. And this is number 2. then this is number 3, then this is number 4. Now I'm saying it now that the reason why we are going this way is because I want to ensure that the OH have a smaller number. So if the OH will have a smaller number, I have to go 1, 2. But 1, 2 will give it 3. So our OH is in position number 2. So if the OH is in position number 2, how then do we name 1, 2, 3? Bromo is in position number 3. That's the two of them is in 3. So I can say what? 3, 3. Dibromo. Abi. Then 1, 2, 3, 4. 4 is the same thing as boot. So you can say butan because there's no double bond, butan. Then our functional group is OH 1, 2. The guy is in position number 2. This is our functional group, position number 2. So 1, 2, butan 2 or you see some people saying 3, 3 dibromo. Then this they say dibromo 2 butanol. 2 butanol is same thing as butan 2 or it's telling us that our OH is in position number 2. Butan 4 carbon, OH position number 2. Bromo they are in position number 3. Is that clear? Now let's look at this other one. Now if you look at this compound that we have here, this compound has 2 functional groups. If you see it very well, it's having a double bond here and it's having a OH here. And I said something now that OH has more priority than the double bond and the triple bond. So let's first think of how to count it. If I go 1, I can write this line formula. I can write it. In case you don't know how to write this, this is the same thing as saying CH double bond, right? To CH, this place will be CH2, yeah, and this is CH, and then this is will be what? Connected to C, that has OH, yeah, then move forward, this will be H, which is here, then this will be what? CH3. Now I've turned the line formula to something you can deal with. So how do I count? Should I go 1, 2, 3, 4? Now that's my longest chain actually. This is the longest chain. Now if this is the longest chain, you can see that we do not have any carbon that all the carbon were counted. So there's nothing like methyl ethyl. But we have a guy here which is what? OH, and we have a guy which is double bond. So should I count 1, 2, 3, 4 or 1, 2? If I count 1, double bond will be in position number 1. 2, 3, OH will now be in position number 3. And I told you that OH has more priority than double bond, meaning that I won't count here because if I count here, my double bond will be favor position number 1, this will be 2, then this OH will be 3. So I won't do that. I want the OH to have the smallest possible number. So let's count from the other side. If we count from the other side, this will be 1, 2. So this place will be 1, this will be 2, this will be 3, and this will be 4. You get that? So 1, 2, 3, 4. OH is in position number 2. Double bond is now in position number 3. I counted this way because I wanted OH to be favored. If I count from here, double bond will be favored, but won't favor OH. OH is the priority when we are dealing with double bond and OH, triple bond and OH. So let's continue with the naming. 1, 2, 3, 4. 4 is boots. 4 is boots. Now don't forget that there's a double bond. 1, 2, 3. Double bond. Yes, position number 3. So you say boots. 3 in, like more like booting, but there's alcohol there, so it's sounding bootino. So this is boot 3 in. This 3 in we have here is just indicating it is there's a double bond at position number 3, then boot 3 in, then 1, 2. Our OH is in position number 2. Our OH is in position number 2. If OH is in position number 2, that will be what? 3 in, 2 or. Is that okay? Or you can say 3 butene, 2 or anyhow you have it. So but when you see this naming, it's telling you that it is butan. It is 4 carbon. 1, 2, 3, 1, 2, 3, 4. Then OH 2 or OH is position number 2, 1, 2 or. Triple bond, triple, double bond is in position number three. One, two, three. That's the way to go about it. So let's look at the number three. Then you are going to answer question four. Let me write the compound out: 5-bromo, 4-chloro, 3-methyl, exam 2 up. You do this yourself, but let me give you answer to this question. Now, this is a cyclo with a functional group OH. So you know that this OH is our priority, position number one. So if I go one, this is one. Should I go 1, 2, 3, 4, or 1, 2, 3? I have to go 1, 2, 3 so that these guys will be smaller. If I go 1, this space will be 2 and this space will be 3. Instead of going 1, 2, 3, 4, they're making the space 5. I want to give them the smallest possible number. So I have to go anti-clockwise: 1, 2, 3. So 2, 3, that will be 2, 3 dichloro. 2, 3 dichloro. How many carbon is this? Right, that's 6. That's cyclohexanol. Hexan 1 or hexanol, because our OH is in position number 1. So if you hear the word hexan 1 or, it's the same thing as hexanol. If you hear the word pent 1A, it's the same thing as pentene. Is that okay? But hexan 2 or is not the same thing as hexanol. Hexanol is same thing as hexan 1 or, and hexan 2 or is different. Is that clear? So I want you to answer this question. Do it as assignment. This one here. Can you see it? So I want you to do this one as assignment. Yeah. So thank you.